G'day. Today I'm continuing on with the Gower drill grinder, and today I'm making up a whole bunch of the little parts and bits and pieces. Nothing's terribly arduous, they just need to be made, so I'm going to just do a whole bunch of those. There are still a few to go, but these are the sort of the main bits and pieces, and then I can get back into making some of the more major parts. But these are, everything needs to be made, so off we go. The first part I'm going to be looking at is this bit. Now this looks like it's been machined out of one piece, but it's actually been fabricated, and that's fine. And so that's what I'm going to do here. It's actually a bit of 25 angle with a bit of 10mm rod welded onto the front, and then welded in there and trimmed back and all the rest of it. So because it's a cold morning, I thought let's do a bit of welding, so we're going to do this bit. So I'll start by welding a piece of rod onto some angle and then whittle that out. And this is the Y bit. That's just a bit of rod that I've turned down to, it's actually 10.2, and I'll explain for the reason for that in a moment. But what I want to do is weld that onto the end of this piece of angle, and I've left it a bit over long so I can come back and trim it off, because what would happen is if I just welded that straight on there, I'd probably have a little bit of a bead where I rounded the corner, all that sort of thing. There might be a little bit of porosity and so on. So I'm making it overly long. I'm then going to weld it up and then trim it back, and I'm hoping that'll give me something that looks a bit like solid metal. This is only a nut for a screw to go through, so it's not critical, but it's always nice to have a good weld rather than a bad weld. Now, the drawing says that this is diameter 10, and the outside surface has 1.5 from there. I haven't got any 1.5 steel, but I have got some 1.6 aluminium, and so I'm going to use the 1.6 aluminium as a spacer, and it's the wrong shape, but if you can imagine that, that'll be against the bench, and that'll be down on the deck, and so I'll get a 1.6 gap. Now, because the drawing says 1.5 on diameter 10, and I'm using 1.6, I've made this 10.2. Pretty straightforward, but it does pay to think a little bit ahead about, well, how are you going to set these parts up before you start doing them. So that's the end result there. I've just got a little bit of a fillet there and a little bit of fillet there. It's still hot, so I'm not going to touch it too much. I'm leaving this long, so I've got something to hang on to in the mill, because I'm going to be taking a cut down there and taking a cut down there. This eventually only ends at about 10mm long. So while it cools, I'll get on with some of the other smaller parts. So I've got my bracket up on the mill, and I've just taken the top down to 21, and as I was suggesting would happen, because of the way the weld is there, not near the start, I've got a clean weld, total fusion, all that sort of thing. I need to just dress that up a little bit, but that's just as was planned. I've got a parallel here pushing against the flat. I don't trust the vise to just sort of clamp across there and it not twist, so by having the parallel in there, it means I've got the force going through the main bit. It rattles a little bit, but it does hold it where it's meant to be. I'm going to give this clamp screw a go. Now, this is a reasonably straightforward part, except for the length. The length is such that if I have that sticking out from the chuck like so, it could well flop around, and there's some fine detail that I need to put in down there. So what I'm going to be doing is actually leaving that a bit long, putting a centre in there, doing all this sort of stuff, and then as the last operation, just removing that centre, so I can then put that into a collar chuck or something on the threaded part, and that'll be all right. And yeah, just bringing that down to flush, and that's how I'm going to do that one. And it's again, it's another one of those worthwhile little tricks that if you've got a long slender part and you'd really like a centre in there, there's nothing saying you can't leave a little bit long, put one in there, and then just take off that little bit of material. Before parting off, I put the cross hole for the bar in there. I've got an M4 by 32 dowel, so I'm going to use that. You could just make up a little cross piece if you wanted to, and then I'll part that off. Now, one word of warning, the drawing calls up an M5 thread, and yeah, that'll do the job. But when I measure the actual unit that I've got, it's actually a 3/16 24 TPI, slightly coarser and probably a little bit better for a job like this. Yeah, just one of those things. Once I've parted that off and done the end treatment there, I'll then come back and work on this end. This is one of my ER40 collets. It's the 5/4 one, so that'll fit quite nicely, and I prefer those when I'm trying to grip a thread. But some of you may have noticed, some may not, that in the smaller sizes, these collets have got a recess, and so that will fit like that, and I can get plenty of access there. So if it was completely, if the bore was complete, I wouldn't get it much past there, but because it's got that recess in the back, I can do that. So that's just a little trick to remember with some of these ER collets. The drawing here calls up a groove, R.75. Now, I wasn't quite sure how I was going to do that, but then I realised that what's going to happen here is that a pin goes through there, and so it doesn't need to necessarily have a rounded bottom. It could be just a square bottom groove. So I've got a parting tool, 1.6. I've used that, and as you can probably see down here, I've got a little square groove in there. This nut on here, I just put on in case I manage to ding up or damage the end of the thread on that. I've got something I can wind off to repair the thread, or at least swage it back to where it should be. It's a problem, particularly with finer threads, but that's one way to get round to it. There's my finished little clampy brackety thing, whatever you want to call it. So the previous clip you saw me machine across the top there. I've come in with a cutter along here and taken that out. I've shortened that up. I've brought a cutter in there to sharpen that corner and put the holes in there, and now everything is all put together. I've tried this screw in here. I had to actually run this through a split die to try and bring it down a little bit. It was a little bit stiff, although I think that's probably because I was using worn dies rather than worn fixed dies rather than a proper sharp one, but that's all right. It turns now. The little button goes on there. I'm not going to do that just yet, simply because I want to see how all this fits together. I'm making a few changes, and so I don't particularly want to fix things in place when I might find that actually I need to lengthen this screw or make this bracket a bit bigger or something like that. This is the handle for one of the locking levers. There's an M6 thread on there. I have to try and find a ball to fit on that, but if I can't, I can make one. Down here I've put a little spigot. And that's just so that I can put a hole in the boss that it goes into and help locate it when it welds, because sometimes you're welding round on round, you've really got to have it clamped up properly. Here are my handle parts. As I said, I've got a hole in there to put that into, so that'll just hold that, and I can clamp that much more easily. It won't start trying to slip off the round there. I then just have to come in and put a bit of weld around there. I'm going to do the holes later. Simply so that any distortion I bring from the welding won't actually affect the hole. I've got myself a little bit out of sequence, but on these handles, I realised I hadn't commented on that. These are just a round boss with a radius on there. You can put a file on there. If you've got a form tool, you can put a form on there. The only real difference between them is that this one is 15 high, and this one, which is used for the slide clamp, is only 9. So that's all good. That piece in there is just a round nut, and the reason for that is that you adjust the nut up to where it grips, and then use a grub screw or something through the handle to lock everything in place. Here's the part with the counter bore in place. I've got a clearance hole there for an M8, which is, I've just done that as 8.5, and then I've put my counter bore in there, diameter 14. There's the threaded bush for inside the handle. If you're wondering how you do that without a surface to grip onto, all I did was I drilled a hole in there when this is on the lathe, ran the tap down and then parted it off, and that gave me enough to clean up. I had to lose 2 or 3 millimeters on the end of the bar, but that's fine. And that will sit in the handle like so. When I come to fit this, I'll nip that up to where it needs to be, put the handle on, tighten up the grub screw, and away I go. One of the last small parts that I'm going to put on this video is a knob. This is the bit that clamps the back of the drill, and that sits onto the banjo like so, and then on the other side there's a knob. Now this is the one that my uncle made up, and he's made this up as an knurled knob, but later on he's come along and added a little crossbar, and I think that's basically because you don't get enough leverage with a knob that small. So rather than do that, and look, I'll put the drawing in to this video so you can, have a go at making one of these if you like. But rather than do that, what I'm going to do is just make up a lobe knob out of aluminium, and I've started it here. In here I'm going to put a sort of a hat section made out of steel, and that'll be tapped with an M5, which is to match that. Part that off, turn it round, dome it, and then go to the mill and just put some lobes, probably 6, in there to give yourself something to grip on. I was just about to part this off and thought it might be worthwhile just explaining why I've done what I've done. First of all, that sleeve or that flange is going to sit around the top of the aluminium knob there. So when I push that in, that's going to bottom out against that. This is, well, I hope it is, an interference fit in here, or but I'll use a bit of Loctite to ensure that. The depth of that hole before it comes in is 11 millimeters. So I'm parting this off at 10. Strictly speaking, I don't need that much thread. As I've said before, over 2 diameters of thread in a nut, and you're probably wasting your time. This at 10. This will be 2 diameters, so that should be ample for that. I've done it this way because, as it is, I can now, when I part that off, I can push that into the knob here, and if I find that it doesn't, the mating screw doesn't go in smoothly, I can run a tap through, because this is where the decent thread is. I think I've got this tapped all the way down through, but if I need to clean it up, because I've got good thread here, I can start it quite easily and do that. So there's the knob that's been domed. That's around about 2.5 millimeters. Did that with some copper there just to shield the part from the jaws, and then just ran the file down in a smooth motion. And then polished the front up with some emery on a backing board. That's a bit of felt, and the reason I have that there is just that it provides just a little bit of cushioning. You could probably do the same thing if you had some soft rubber. That's a reasonably hard felt, and unfortunately it's getting harder because of the way it's being used. But that way I get a polished finish. I'll set that up in a dividing head, I think, and just come in and put some scallops in there, just enough that you can get your fingers in and twist that. One thing I was going to mention too, for those of you who like a bit of bling, before pushing that steel knob in, you could actually put the scallops in there, do all the rest of it, but not push the knob in, and then send this out and get this anodized. And then push the knob in, push the threaded bush in as a last thing. So, this style of knob has got a lot of advantages to it. You've got a steel thread, so you're not going to wear something out, but it's aluminium, so you can do all sorts of things to put, fancy colours and things like that on it. Reasonably easy to shape and polish. So I like this style of knob, and I'll be using this on the side of the drill grinder. For those keen on making a knob like the one I'm making at the moment, this is the basic dimensions. I've made this up just as a sort of a by eye thing, but this is what they come out with. The doming is 2.5 millimeters. I've got 6 lobes made with a diameter 16 cutter, 3 deep, which takes it about to the halfway mark there. I've put a chamfer on that little steel plug just to help ease it in there. I think I had a thou or two interference, so that was nice. I was able to do that in the bench vise, but that's the basis of the knob. That's the finished knob after a bit of polishing and deburring and all that sort of thing. I mean, as your fingers are going to be on that, you will need to make sure that it is properly deburred, but that's good enough for me. And as you can see from those ribs, they're only 3 millimeter deep, but they're good enough that you can really get your fingers in there and grip. One of the things I did use to deburr was one of these, a little, what would you call it? Flat something or other. Specialist abrasive shops have got them, but very handy for getting into those small grooves and things like that. I've got a little bit of chatter there where I fed in a bit too fast, but I can live with that. That's okay. So yeah, last of the small parts for the moment anyway. Thanks for watching, and we'll see you for the next one. And for those new to the channel too, don't forget there's a whole bunch of stuff in the back catalogue worth having a look at. You might find something of interest. There is, for example, another video on making knobs of this sort and other sorts as well.